Remember that a function is just a relationship between variables, and we can view functions as machines that take in some input and produce some output. For example, f of x equals the square root of x is a machine that takes in a number, like say 4, and outputs the square root of that number, in this case 2. At some point you had to learn what that symbol square root meant, right? It means think of a number that multiplies by itself to give you whatever is inside here. The trigonometric functions are sine, cos, and tan, and we likewise have to learn what is meant by the symbols sine, cos, and tan. Here are the definitions. The trig functions take an angle as input and give a ratio as output. In particular, you have this triangle right here, where your input is the angle. Now, we could denote the angle by x as the independent variable, or we could use any letter that we want. Sometimes, often, for angles, we like to use the Greek letter theta. So these are functions f of theta. That's our independent variable here. F of theta equals sine theta. Okay, so we have this triangle, which is a right triangle, and one of the angles is the input angle theta. Then you measure the 3 sides, which we're going to call opposite, the one across from the angle, adjacent, and hypotenuse. Then sine theta, f of theta equals sine theta, is a machine that takes an input theta angle and outputs the length of this opposite side divided by the length of this hypotenuse side. That's all sine is. Cosine is adjacent divided by hypotenuse. Tan, depending on how you want to write it, it's opposite over adjacent, which is the same as sine over cosine. Now, how do we see that? Well, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and we know that to divide fractions, we can multiply by the reciprocal. If we do that, the h's cancel, and you get opposite over adjacent. So tan can either be seen as sine over cos or opposite over adjacent. Again, remember that these are functions that are taking some angle as input. If you just wrote y equals sine with nothing else, just nothing here, then that's just as meaningless as writing y equals an empty square root sign with nothing inside of it. Sine, cos, and tan have to have input. The angle that we're taking and putting into these functions can be measured in radians or degrees, and the sine and cos and tan will work the same. However, other things we're going to do with these functions are only going to work if the angle's in radians, so we always want radians in calculus. Another thing you might be worrying about is, what if I drew a different sized triangle? What if I drew the same angle theta, and drew a little tiny triangle? Then this length and this length are going to be different. So wouldn't that give me a different answer for sine? Well, a wonderful fact about mathematics is that similar triangles like this, which have the same angles, the ratios of sides are equal. So in fact, the opposite over hypotenuse in this triangle is exactly the same as the opposite divided by hypotenuse in this side. That fraction is going to be the same. Like maybe this is 3 and 5 and this is 30 and 50. And when you reduce it down, you get 3 over 5. So you should rest assured that the sine, cos, and tan functions are all well defined. You're not going to get different answers depending on which triangle you draw. We prefer to measure the angle in radians because then f of theta equals sine theta, or any of the other functions, is a function with domain all real numbers. Now, to know what we mean there, we have to maybe review what a radian is. A radian is, if you have an angle, like this angle right here, then a radian is the length of this arc divided by the length of this radius, arc length, divided by radius. So for example, maybe it's 1 centimeter divided by 2 centimeters. What happens then is the centimeters, the units cancel, and you just get a ratio which has no unit. So this is just a real number. So So radians are just real numbers. So when we measure the angle theta in radians, then this function f of theta equals sine theta has domain all real numbers. There are three other trig functions, and these are just the reciprocals of the other three. Cosecant is equal to 1 over sine. So the cosecant of a specific angle is 1 divided by the sine of that angle. Secant is 1 over cosine. I remember these because CS, SC, they switch. And then cotan is 1 over tan. Now, tan is in turn sine over cos, so we can simplify this and get it just in terms of cos and sine. Flip it over, multiply by the reciprocal, right? It would be 1 times cosine divided by sine. And we get cotan is cosine divided by sine.